Okay, this problem should be in your workbook, so what I would like you to do now is to try this problem first and then come back to the video and see how you did. So go ahead and push pause now and then come back when you're ready. Here we go. In this problem we have this rocket. It's going upwards at 5 meters per second squared and then shuts off the engines, keeps moving, and then falls back down to Earth. So I would recommend, as always, just doing maybe a quick sketch of what's going on. We have our rocket. It's accelerating initially, so it's on its way up, right? So during this time it's accelerating at 5 meters per second, and then it shuts off the rocket. So it's gonna, since it's already moving up, it's gonna keep moving up, and then under the influence of gravity it's gonna head back on down. Alright, so there's really two situations. There's this acceleration when we're going up, and then there's this acceleration of just gravity once we've turned off the rockets. Okay, for simplicity, by the way, I'm going to be using this acceleration, little g, as -10. If you use -9.8, that's fine. Actually, it's better, but just for simplicity, we're going to use -10 here. So let's do it for the first 3 seconds. So for the first 3 seconds, we know our velocity is 0, and then we know that our acceleration is going to be 5 meters per second per second. And so after 1 second, that means, well, we're going to be traveling 5 meters per second. After 2 seconds, we're going to be traveling another 5 or 10. And after 3 seconds, we're going to now be traveling 15 meters per second. So it should be pretty straightforward to fill out those first 3 times. And actually, once we shut off the engines, now we know our acceleration is going to be little g, which is going to be -10 meters per second squared. And actually, since I use this number, this math should be easy as well. At time 3, we're going 15, then we're decelerating at 10 meters per second squared. So a second later, we should now be traveling at 5, 15 minus 10. And then another second later, we should go from 5, and then -10 means we're going -5. So notice sometime in between 4 and 5, we actually hit the peak. We reached our velocity of 0, and you can probably see pretty easily what that time was. That must have been exactly 4.5 seconds, right in the middle there. All right, at 6 seconds, we're now going to be moving another 10 downwards, so -15, and then finally 25 downwards. So that should be your data table that you're going to start with. Let's go ahead and construct our graph at this point. So we're going to go 1, 2, 3, 4, 5, 6, 7. This is our time over here. And so our velocity, we are going negative, so probably we go down to -25. Let's start at -30, -20, -10, 0, +10, and +20. This would be our velocity side. Okay, and then just go ahead and plot your points. So we got 0, 0, we got 1, 5, we got 2, 10, we got 3, 15, we got 4 all the way down to 5, 5 we got all the way down to -5, 6 we have all the way down to -15, and 7, -25. Okay, and these are linear, as you can clearly see, so let's go ahead and connect these with lines. Okay, the reason it is linear is because, well, if you were to find the slope of this would give us our acceleration, right? And we know the acceleration from here to here was +5, and we know the acceleration from here to here was -10, and that was constant, right? So that's what's giving us our linear graphs. Okay, so that's our graph. Next step is we're now going to use this graph to find our position time graph. So there's a couple ways you could do that. I'm going to do it just using the area. So remember, if we find the area of a velocity time graph, that will give us our our displacement. So let's go ahead and do that. So we're going to just assume here that our initial position is 0. So at time 0, we're going to go ahead and say our position is also 0. Okay, and this will be in meters. And you could do this for each point if you wanted. It's not really necessary. We're just going to look for the extremes. So we're going to go all the way from here, from 3 seconds. At time 3 seconds, find our position. And again, you could plot this at 1 second, 2 seconds, 3 seconds. But for simplicity, we'll just go all the way to 3 seconds, and then we should know how to sketch it in between. So this is going to be 3 seconds. We're going to find the area underneath this triangle. That's going to be 3 times 15 divided by 2. So that should give us 22.5. Okay, now we're going to find the area. Now for this one, you're not finding the area all the way down here. We're just going to find this area from here to here. Okay, and we want to find this point here. Now in this problem, it was fairly straightforward to find where this was. If you didn't quite know how to do that, one of the ways you can figure that out is say, okay, at this point, this is going to be a velocity of 0. I want to find out when that velocity is 0. So what I can do is say, I want my velocity to be 0, and find out how long it takes for my v to become 0. So if we start at, say, point 3, at point 3 we know we're moving 15 meters per second. We know now we're under the influence of gravity, which gives us an acceleration of negative 10 meters per second squared. Alright, and then we can find out how long it takes, or what the time is going to be, to figure out what that, when we reached our peak, when we had a final velocity of 0. Right, and so when we do that, we get 15 plus negative 10 times t. And you can say t is 1.5 seconds. And so it would be 1.5 seconds beyond the 3 seconds, which is 4.5 as we determined before. So anyway, if the numbers are not so nice, that's kind of how you'd want to go about finding where it is at the top. Let's find this area then. So this is 1.5, right? And this is 15. So let's find the area of this. 1.5 times 15 divided by 2, and that's going to give us 11.25 meters. Now remember, this is a displacement, so that means from this point to this point we travel 11.25 meters, which means our position would be 11.25 plus 22.5, where we were located at time 3. Okay, the final thing is going to be all the way down here to 7 seconds. So this is going to be at time 7. We want to know where we're located. So again, we're just going to find the area of this. This is negative 25. This is, what's this, 2.5. So we'll go ahead and find the area of this. Now remember, since we're underneath the axis here, we are going to have a negative displacement. We're going backwards, or in this case, we're going down. So negative 25 times 2.5 times 1/2. Let's go ahead and do that. So negative 2.5, negative 2.5 times 25 times 1/2 gives us negative 31.25. So again, that would be the displacement from our peak. And at our peak, we determined already we were at 33.75. So we're just going to subtract that from 33.75. Looks like 2.5 is our new position. Alright, so let's go ahead and plot these. We've got 4 points to plot here, so we're going to go all the way from our maximum height is going to be 33.75, so let's just go ahead and go by 10s. So we got 10, 20, 30, 40. Okay, again, this is going to be our position. This will be our time. Okay, in seconds. So we're going to go 1, 2, 3, 4, 5, 6, 7. Remember, the other important point would be right here. This was our peak. That was when we reached the peak at 4.5, right? That was way up here when we're at velocity of 0. Let's go ahead and plot this. So we're going to go 0, 0. We're going to go 3 all the way to 22.5. So that's going to be approximately right there. We have our 4.5. That's when we reached our peak. That's about 33, 34. And then finally at 7, we're almost down at the bottom. So about 2.5, that's going to put us right there. So if you remember, the way that we connect these is we look at what's going on with the acceleration. So from 0 to 3, remember we had a positive 5 acceleration. So positive acceleration means our graph's going to be concave up. And then from 3 all the way down to 7, we had a negative 10, right? Negative acceleration. That's going to give us a concave down. Okay, so 0 to 3. So this, you're just going to kind of ballpark it. And if you want to be more exact, you could actually plot the 1 and 2 seconds. That'll give you a little bit more accurate curve. We're just sketching this out here. So we're going to sketch a concave up curve between 0 and 3. And then from 3 to 4 and 4 to 7, it's going to be a concave down curve. So again, you could plot more points if you want this to be a little bit smoother, a little bit more accurate. I'm just going to try to make sure I create this concave down type curve, something like that. Okay, and that would be our graph. All right, I think there were 2 more questions for us to answer. What is the maximum height reached by the rocket? So we actually already figured that out, right? That was right here. That was when the velocity was at 0, which means that's our peak. Oops, I noticed a mistake here. Hopefully you guys caught this. This should be a time of 4.5 seconds. So anyways, that should be 33.75. Should be our max height. H max equals 33.75. The final question is, when will the rocket hit the ground? Well, you can tell from this graph that it's almost on the ground, so it should be something a little bit more than 7. And there's multiple ways to get the exact number. The way I would probably do it is I would say, how long does it take to go from 4.5 from the peak all the way to the ground? What's the time it takes to go from the top to the bottom? And the reason I'm doing that actually is because we know the velocity here is 0. And whenever you can get one of your variables to be 0, that simplifies the problem. So let's go ahead and set up what we know. So we know our v initial is going to be 0 at the peak. We know the acceleration is -10. And we know the height it's going to drop, right? It's dropping that 33.75 distance, so delta D is, let's going to put negative because it is dropping, and we're looking for time. So we're just going to use our kinematic equation. We'll use this one, VOT plus 1/2 AT squared. And let's go ahead and solve it. -33.75, 0 plus 1/2 -10 t squared. Okay, solve for your t. Let's do that. So we got -33.75 divided by 4.5 equals 6.75, and then don't forget to square root that. Oops. Square root answer. 2.598, about 2.6. So say that takes 2.6 seconds. Now that's after the 4.5 seconds. So if we add 4.5, that'll give us our total, and 7.1. Which is, about what we thought. Okay, it's almost going to hit the ground at 7 seconds. Alright, if you have any questions about this, please ask them in class.